So we spent some time really looking at converting between moles and molecules and even correlating that with grams and molar mass and all of those things. So let's go ahead and pull all of this together and do some extra examples. Kind of going easy, medium, and hard here. First up, what do we have? How many oxygen atoms are there in 4 grams of sodium dichromate, Na2Cr2O7? So it's telling me what the species is, and I just need to know how much I have of it. First thing you want to write down is what you're trying to find. You're trying to find the number of oxygen atoms. The next thing you want to write down is what you're told. You're told you're starting with 4 grams of sodium dichromate. Now, I cannot go straight to oxygen here. I do have to go through the moles of sodium dichromate before I can go straight to oxygen. Because oxygen was in that formula, yes, but first I need to go to moles of sodium dichromate because that's the grams I have. Okay. So I know that 1 mole of Na2Cr2O7 weighs 262.0 grams. How do I know that? Because I added it up. So again, if you hadn't seen it in my previous video or if you forgot, if you're ever unsure, great website, ptable.com. Periodic table, it's interactive. It's got a lot of extra information you're going to be using throughout Chem 1 and Chem 2, especially later on in Chem 1. Great website. You should always have a paper periodic table with you when you're studying, but if you're working on your iPad or your computer and you just don't have one, this is a great website to use, okay? I go here and I see that sodium itself has a molar mass of 22.99 grams per mole. I have 2 of them, so I multiply that by 2. Chromium has a molar mass of 52.00 grams per mole. We always want you pulling 4 sig figs off that table. I have 2 chromiums, I multiply that by 2. Oxygen is 16.00 grams per mole. I have 7 of them, so I multiply it by 7, and that's how I got that 262.0. Oops. Now that I'm in, so this is canceled out my grams of sodium dichromate. Now that I'm in moles of sodium dichromate, though, now I can use my formula to convert to just moles of oxygen. Remember, you can get mole conversions from your balanced equations and from your formulas themselves. I see here that 7 moles of oxygen are contained in 1 mole of sodium dichromate. That cancels out my moles of sodium dichromate, and now I've got just moles of oxygen. Now that I got moles of oxygen, I can go ahead and convert to number of oxygen atoms. 6.022 times 10 to the 23rd oxygen atoms is 1 mole of oxygen atoms. So that cancels out. Plug this in your calculator, and you should get out 6.44 times 10 to the 22nd oxygen atoms. So again, I had 3 sig figs here, 4 sig figs here. This is an exact conversion, so it doesn't limit sig figs. 4 sig figs here. My final answer can have 3 sig figs. What's our next one? Okay, calculate the number of atoms in each sample. I've got chromium, platinum, and sulfur. So let me find where I have these ones written down so I don't have to actually pull out a calculator right now. Okay, chromium, 14.955 grams of chromium. So trying to find the number of chromium atoms. I have 14.955, I apologize, grams of chromium. Before I can go to number of moles of atoms, I have to convert to moles because again, I don't have 1 mole here, I have a portion of a mole. And so converting to moles first accounts for how much of the mole I have, so I can count for how many atoms I actually have. 1 mole of chromium weighs 51.996 grams, or normally I would just pull 2 sig figs off of the table. So 51.996, you can absolutely just round that to 52.00. We want you pulling 4 sig figs off for molar mass. Beyond that, not picky. 4 sig figs is perfect. This cancels my grams of chromium and gets me to moles of chromium. But I don't want moles of chromium. I want number of chromium atoms. So 6.022, 10 to the 23rd chromium atoms for every 1 mole of chromium. Plug that in the calculator. 1.732 times 10 to the 23rd chromium atoms. And it's hard to see the way I wrote that, but it should be a capital C and a lowercase r. So this had 5 sig figs in it, but the way I took my molar mass only had 4 sig figs. And I did that because of Avogadro's number. I only have memorized 4 sig figs. So my final answer here can only have 4 sig figs. Which one's next? 12.899 grams of platinum. So number of platinum is PT, atoms. I've got 12.899 grams of platinum. I look at the periodic table, I find platinum, and I see that platinum has a atomic weight of 195.08, which I'm going to round to 195.1 grams. So that means 191 point, AMU, 195.1 grams of platinum would equal 1 mole of platinum perfectly. Cancels my grams of platinum and gets me to moles. But I don't want moles, I want atoms. So 6.022 times 10 to the 23rd platinum atoms is 1 mole of platinum. Calculate that out, and you should get 3.982 times 10 to the 22nd platinum atoms. Stack sig figs. This had 5 sig figs, but this only had 4 sig figs. Then this only had 4 sig figs. So my final answer can only have 4 sig figs. Because again, multiplication division looks at the number of sig figs you have. And sulfur, 39.733 grams of sulfur. So I want to know the number of sulfur atoms. I'm starting off with 39.733 grams of sulfur. 1 mole of sulfur weighs 32.07 grams. I pulled that off the periodic table. 6.022 times 10 to the 23rd. Sulfur atoms in every 1 mole of sulfur gives me 7.461. So really this calculates out to 7.4609, but I need 4 sig figs times 10 to the 23rd sulfur atoms. So again, your grams have canceled, your moles have canceled. I've got sulfur atoms here. I had 5 sig figs here, but I only have 4 sig figs here and 4 sig figs here. So I have to round this to 4 sig figs here as well, which is why I'm rounding that 0 up to a 1 because I'm dropping that 9. Okay? Let's see. If a copper penny 1980 has 2.94 times 10 to the 22nd copper atoms, what will be its mass? The reason it's emphasized in the year there, I realize most of you won't care, but I'm going to give you a history lesson anyway. Copper is expensive, and so it's expensive to process and it's expensive to put into pennies. And so back in 1983, they switched the penny from being primarily copper to just being a copper coating, so it still has the color. Current pennies are primarily zinc with just a copper outing or they're in a copper shell. And so I picked 1980 because I was born that year and I think it's fun. So there's your random history lesson in chemistry class. Okay, so let's see. Back to the actual focus here. I have a penny, and I'm going to assume it's 100% copper. Makes life a slightly easier. We'll do an example in a minute that is not 100% copper. Okay, so we'll see that example in a few slides. What I'm trying to find here is the mass of the penny. Well, if the penny is 100% copper, what I'm really looking for is the grams of copper. Because the penny is just copper, therefore the mass of the penny is the mass of the copper. I'm told I have 2.94 times 10 to the 22nd copper atoms. I can't go from atoms to mass. I don't have a conversion, but I can go to moles. 1 mole of copper is 6.022 times 10 to the 23rd copper atoms. Now that I have moles, now I can go to mass. Because I look in the periodic table and I know that 1 mole of copper atoms weighs 63.55 grams. How do I know that? Because that's what's listed for copper on the periodic table. I cancel out my moles and gives me my grams. I calculate this out and I get 3.10 grams of copper. That is a zero there. 3 sig figs, 4 sig figs, 4 sig figs, 3 sig figs. So if it had 2.94 times 10 to the 22nd copper atoms, that penny would weigh 3.10 grams. I can't forget that zero on the end because I need 3 sig figs in my answer, so I have to add that zero on the end. Okay, what's next? How many phosphorus atoms are there in 4.29 grams of aluminum phosphate? Well, what are we trying to find? We are trying to find number of phosphorus. First thing I do is I write down what I'm trying to find. Next thing I write down is what I'm given. I'm told that I have I'm told that I have 4.29 grams of aluminum phosphate. Let me see. Sorry, I do have most of these calculated behind the scenes, so I don't have to pull out my calculator. There it is. And it's easier to do it than trying to pull out my calculator and make you wait for that. Okay. First thing I need to do is convert to moles. But again, I'm not going to just moles of phosphorus here because this is the grams of aluminum phosphate. So I need to convert to moles of aluminum phosphate. But I need to add up what that is first. So 3 aluminum, 3 times 26.98 grams per mole. Again, remember the 2 distributes through. So 2 phosphorus. Phosphorus is 30.97 grams per mole. And then 2 times 4 oxygen, 8 oxygen, 8 times 16 grams per mole. When you add all that up, you're going to get 270.9 grams of aluminum phosphate. So this step is just converting those grams to moles. I'm only interested in phosphorus though, so let's look at phosphorus. I see that there are 2 moles of phosphorus in this formula for every 1 mole of aluminum phosphate. So that means if I had an entire mole of aluminum phosphate, I would have 2 moles of just phosphorus present. That step got rid of my moles of aluminum phosphate. Now I'm in moles of phosphorus. Now I can easily calculate to the number of phosphorus atoms. 6.022 times 10 to the 23rd phosphorus atoms for every 1 mole of phosphorus. Cancels out my moles of phosphorus. Give me my number of phosphorus atoms. I plug this in my calculator and I get 1.91 times 10 to the 22nd phosphorus atoms. Really quickly check your sig figs. You got 3 sig figs here, 4 sig figs here. This is exact, so it doesn't limit my sig figs. 4 sig figs here, and 3 sig figs in my final answer, limited by that original number. Okay, which one's next? How many hydrogen atoms are there in 1.32 moles of magnesium carbonate or magnesium acetate? I apologize. So first thing I want you to do is write down what you're trying to find. You're trying to find number of hydrogen atoms. Next thing you should write down is what you're starting with. And here you're starting with magnesium acetate. We're starting with moles, not grams, so slightly easier. 1.32 moles magnesium acetate. Now, I don't have to Excuse me. I don't have to convert to gram or to moles here. I'm already in moles, so that makes my life easier. I don't have the molar mass of magnesium acetate. I don't need it. I'm already in moles. But I don't want magnesium acetate. I want hydrogen. And when I look in here, I see the 3 there, right? But don't forget the 2 out front applies to all of it, which means I really have 6 moles of hydrogen for every 1 mole of magnesium acetate. Basically, what that formula is 1 magnesium ion and 2 acetate ions. That's the entire compound. So I really have 3 and 3, 6 hydrogens overall. But I got two moles of hydrogen, so I can go ahead and go to number of hydrogen atoms, 6.022 times 10 to the 23rd. Hydrogen atoms for every 1 mole of hydrogen. So I have canceled out my moles of magnesium acetate. I've canceled out my moles of hydrogen. I'm into hydrogen atoms. I calculate this through, and I get 4.77 times 10 to the 24th hydrogen atoms. Just to check, 3 sig figs, exact, and 4 sig figs. So my final answer will have those 3 sig figs that are shown. See what's next. How many moles of aluminum are contained in 3.7 times 10 to the 24th aluminum atoms? Okay, so again, write down first what you're trying to find. You're trying to find the number of moles of aluminum. Second thing you should write down is what you're given. You're told you have 3.7 times 10 to the 24th aluminum atoms. I just want to go from moles to atoms, or atoms to moles in this case. It's pretty straightforward. I want to find moles, and I know 1 mole of aluminum contains 6.022 times 10 to the 23rd aluminum atoms. Cancels out my aluminum atoms, it gives me moles of aluminum. Plug it on my calculator, and I get 6.14 moles of aluminum. Again, let's just talk about sig figs really quick and check them. Here, let's see, I actually, to fix my sig figs, I have 2 sig figs here. I have 4 sig figs here, which means that this is not correct. I can only have 2 sig figs. So I need to round this to 6.1 moles of aluminum. That's why we always check, because I very, very often do 3 moles or 3 sig figs. But in this case, 3 was not correct. I need to just keep it to 2 sig figs. Let's see, how many chloride ions are in 25 grams of aluminum chloride? So write down what you're trying to find first. Number of chloride ions. Chloride is Cl minus. 25.0 grams AlCl3. First thing you want to do is convert this to the moles of the species you have. So we're told here that we have aluminum chloride, so I need to find the molar mass of aluminum chloride. 1 aluminum, 26.98 grams per mole. 3 chlorines, 3 times 35.45 grams per mole. Now, in this formula, it's actually chloride ion and aluminum ion, but remember, ions in the original atoms basically weigh the same because it's just the gain or loss of an electron. An electron is 1/2000th the mass of a proton or neutron, so it doesn't make a difference to the overall mass. Convert to moles first. 1 mole of AlCl3 weighs 133.3 grams. So this step here, just convert it to moles of AlCl3. Then you look at your formula and you see you have 3 chlorides for every 1 aluminum chloride. That cancels out my moles of aluminum chloride and gets me to my chloride only. I don't want moles though, I want number of ions. So times 6.022 times 10 to the 23rd Cl minus ions for every 1 mole of Cl minus. Calculate this through. You get 3.39 times 10 to the 23rd Cl minus ions. Now let's check your sig figs. 3 sig figs, 4 sig figs, exact. 4 sig figs. So my final answer can have 3 sig figs. What's next? How many molecules of glucose, C6H12O6, are present in 25 grams of glucose? So, number of C6H12O6 molecules, and I'm starting with 25 grams of that species. One mole of glucose, add that up. You've got 6 carbons. Carbon weighs 12.01 grams per mole. You got 12 hydrogens. Hydrogen is 1.008 grams per mole. And 6 oxygens. Oxygen is 16.00 grams per mole. When you add that up, you're going to get 180.2 grams for the molar mass of glucose. So again, this just cancel out my grams. Now I've got moles. Now that I got moles, I can use Avogadro's number. 6.022 times 10 to the 23rd C6H12O6 molecules for every 1 mole of C6H12O6 molecules. Calculate this through, and I get 8.36 times 10 to the 22nd C6H12O6 molecules. And the moles here have canceled. Let's check your sig figs. 3 sig figs, 4 sig figs, 4 sig figs, 3 sig figs. So that is the correct answer. What's next? What is the mass in grams of 3.77 times 10 to the 10th water molecules? So I want the number of grams of water if I have 3.77 times 10 to the 10th water molecules. I may not know what it is, but I do know that number is pretty small. So I don't know where I wrote that one down, so we're gonna use a calculator. Okay. First thing I do is convert to moles. So I've got molecules there. So I need 1 mole of water, contains 6.022, 10 to the 23rd water molecules. That cancels out my water molecules and gets me moles of water. I don't want moles, I want grams. And I know the molar mass of water is 18.02 grams. You've got 2 hydrogens, 2 times 1.008 grams per mole, and 1 oxygen, 16.00 grams per mole. That's where I got the 18.02. That cancels out my moles, and let me plug this in the calculator quick. 3.77 e to the positive 10 divided by 6.022 e to the 23rd times 18.02. 1.13 times 10 to the negative 12 grams of water. I gotta emphasize what units I have here, and it is grams. So let's check our sig figs. 3 sig figs, 4 sig figs, 4 sig figs. My final answer will have 3 sig figs. Okay, what's next? How many copper atoms are present in a 2017 penny with a mass of 3.10 grams? Modern pennies are 97.5% zinc and 2.5% copper. So this is where I was talking about the fact that we have to pay attention to what the penny is actually made of. This gives us an extra conversion we have to do. Okay. So what I want to know is the number of copper atoms. The penny weighs 3.10 grams, but that is the whole penny. Only 2.5% of it is copper. So I treat that as a conversion. 2.5 grams of copper for every 100 grams of the penny. Because this is called percent by mass, meaning 2.5% of the mass is due to copper, 97.5% of the mass is due to something else, in this case, zinc. This conversion here, though, gets me out of pennies, out of grams of pennies into grams of copper. And so this shows me how much of that actual 3.10 gram of the whole penny is just due to the copper. Now I've got grams of copper, I can go to moles of copper. 1 mole of copper weighs 63.55 grams. And again, that is from the periodic table. That gets rid of my grams of copper. I've got moles of copper. Now I can use Avogadro's number, 6.022 times 10 to the 23rd. Copper atoms to every 1 mole of copper. Plug that in the calculator, and I get out 7.34 times 10 to the 20 copper atoms. Now let's check our sig figs. We have 3 sig figs here. Here I actually only have 2 sig figs. That 2.5 is only 2. If I wanted 3 sig figs, I would have to write 2.50. It's only 2 sig figs. 4 sig figs here, 4 sig figs here, which means this answer is limited to just 2 sig figs. So 7.3 times 10 to the 20 copper atoms is actually the correct answer here with the correct sig figs. So the first one is correct answer, but not correct sig figs, so you wouldn't get full credit. What's next? Looks like our last example. The density of copper is 8.96 grams per mil. How many copper atoms are in a sphere with a volume of 0.475 centimeters cubed? Okay, well, let's figure that out. What am I trying to find? Number of copper atoms. I'm starting off with a sphere. I have two numbers here. I have a number and I have a conversion. I like starting with the numbers. I have 0.475 centimeters cubed of copper because that's my sphere. It's just copper, right? It's just how many copper atoms are in the sphere. I have centimeters cubed, but my density is in grams per mil. So I need to remember that 1 milliliter of anything is equal to 1 centimeter cubed of that thing. That converts my centimeters cubed to mils. Now I can go ahead and use my density. I see it's 8.96 grams of copper for every 1 mil of copper. I'm in grams of copper, so I can go to moles. 1 mole of copper is 63.55 grams of copper. And now that I'm in moles, I can use Avogadro's number. 6.022 times 10 to the 23rd copper atoms every 1 mole of copper. Calculate this out, and I get 4.03 10 to the 22nd copper atoms. I'm trying to write the capital C. Now let's check our sig figs. 3 sig figs here. This conversion is exact, so it does not limit my sig figs. 3 sig figs here. 4 sig figs here. 4 sig figs here. So 3 sig figs here. So 4.03 times 10 to the 22nd is the correct answer.